Hello and welcome to the new case study for predicting the heart disease. So if you see the column over here is the heart disease. So this data set or this practice data set is from the UCI machine learning library, as probably most of you may have known about this, or if you don't know, you can write it in the Google about the UCI machine learning library and you will find a lot of good practice data set. So this data set is also from there, and it's basically based on the last two case studies, the solved case studies which I have put together and posted on the YouTube. So that means if you are doing this case study and finding it difficult based on the questions that I will be asking, which I will show you one by one here in this column N, then you can take a reference from those case studies as to how to solve them, right? If you already have seen those and want to practice, then you can practice based on the questions that I'm giving you here. And this data set is also present in this in the Google Drive, which I keep it. It's under the case study. Under the data set folder, you have the case study folder, and you have this hard.csv file, which you can take as which is nothing but this one. Right. So what I'm showing you is not the CSV file, but it is an Excel file, since I just have to add the couple of, if you will see the some more comments about each of these variables so that I can at least explain you, right? Some of them are very self-explanatory, like age, sex, whether it is a male person or a female person, and whether the person is having the heart disease or not. 0 indicate no heart disease, 1 indicate the person is having the heart disease. So I think it is a good data set through which you can practice your skills about the classification algorithm. So it is a binary classification problem, as you would see, that we want to basically develop an algorithm that can basically take the input of these variables and predict whether a person will going to have the heart disease or not. So think it about like this one. Let's say you are an aspiring data scientist, and definitely that's why probably you are looking at it, or you are maybe exploring and want to explore exploring some of the medical related scenarios, right, about how you can predict the disease before it is happening. So this can serve as a very basic and a starter information as to how really with the help of the machine learning algorithm you can do the prediction, or even you can develop some small application which is of general use that can basically tell a person whether the person is having the heart disease or not. Obviously, some information about whether that they need to basically tell all of this information, maybe via some test or something. Or you may be, let's say, about to join the or planning to join a pathology lab. I think that's what, at least what we call in India. They basically do all the testing, like general health checkup and all, and collect all of this information like cholesterol, fasting blood sugar levels, ECG, resting BP, and all of those things. And they basically give, or the doctors basically give the information whether you are normal or not. Now in this specific case, this is related to the heart disease, right? And you want, let's say, doctor to give a conclusion that something is not right and the person may have the heart disease looking at the history of the data. So what I'm showing you over here, or the data set that is being given to us, basically has the history of patients of different ages, different male, different sexes like male and female, and there are different parameters that is being given, and accordingly it's been concluded or identified whether they are having the heart disease or not. So like I was saying, some variable we need to supply. So age and sex is basically two variable, very clearly understood. Then you have this chest pain type, and if you would see it's like an abbreviation like ATA, NAP, and all of those. They are like TA is typical angina. ATA, I'm not very expert into this. So ATA is atypical angina, and NAP is non-anginal pain, and ASY is asymptomatic, right? And then you have the resting BP, like resting blood pressure measured in mmHg. And then you have the cholesterol measured in mmTL, very common thing today, that having the high cholesterol, even I'm having it. So fasting BS is fasting blood sugar, if fasting BS is greater than 120 mgdl, 0 otherwise. Resting ECG, electrodiagram results, normal is normal, ST is having STT wave abnormality, and LVH is showing probable or definite left ventricular hypertrophy by Estes criteria. I really have no idea what that means, what it really means. This is heart rate, maximum heart rate achieved between 60 and 202. And then you have the exercise angina and old peak and the ST underscore slope. The slope of the peak exercise ST segment up is upsloping, flat is flat, down is downsloping. I think this is, if I'm not wrong, this is about those treadmill, on which sometimes when I have gone for a health check, they were asking me to basically walk and run on the flat slope or the flat treadmill, and then they inclined it like a hill walk or a hill run sort of a thing, and they were basically checking heart rate. I'm hoping, I think that's what it is. And then finally what you have is the heart disease, whether a person is having the heart disease or not. Okay, so with the help of this, some of the questions that we are trying to answer is like the one over here. If I turn that into a black, just want to keep the suspense about the next question. All right, so first thing is you need to import the data set. So irrespective of the tool that you are using, let's say you are using Python, you are using, I don't know, R, Julia, or any other software which is basically to do the machine learning or the data analytics, even Tableau or Power BI up to a certain extent, like those type of tools can be used in collaboration with obviously like Python or R, through which you can run the algorithm. So if you are expert over there, you can use that. But the whole idea is down to this problem, how we can make it so self-intuitive, or at least a machine driven by a machine learning algorithm, so that we can quickly predict whether a person is having the heart disease or not. So like a small app. So first thing first, you need to import the data set, right? The CSV data set. And after that, you need to check how many rows you have in the data set, actually how many rows and columns that you have in the data set, so that you can get a feel of the data set about what type or how big or a small data set that you are dealing with. You can clearly see the number of columns over here, but you don't know how many rows are there. So this can helpful in scenarios like those. Let's say if it is an interview question as to why it is important to check the shape of the data set. So maybe pause the video and think about for a minute why it has been asked. So in my view, the reason for asking this question, or what probably interviewer is trying to understand from you, is that do you really know about how big data set, or do you really identify first how big of a data set that you are dealing with, and accordingly you shoot you run your commands, because some commands are very simple, like viewing the first 5 rows or showing the last 5 rows and things like those. But some commands, like for example, if you are plotting something, or if there is a correlation that you are trying to do, or if you are trying to summarize the entire data set or plotting, they take a lot of resources, right? And if you are dealing with a huge data set, that means you will going to have you will going to need a lot of computation. And maybe the next question comes after that in slightly intermediate to advanced level as to how would you improve it, right? If let's say you are dealing with a data set which is having, let's say, 1 billion rows over here, right? So writing a simple command even to summarize the data set may even take from good number of seconds to even a minute, right? Because this is a huge data set. So how would you improve? That can be the next question. So this is the type of a question we need to keep in mind, or at least I have kept in my mind, based on why I write this. So every question that I'm showing you here is somehow you should relate it, that it is let's say an interview question. And as I show you the question, think about it, pause the video at that time and think about the scenario, or think about it when it will going to be asked, or why it will going to be asked in the interview, right? So coming back to the question, check how many rows in columns you have in the data set, right? Now the next question is review the data type of each column. So again, think about it on the scenario. Let me know in the comments if you don't know. I will help you understand that. But this is something which I have discussed in my previous case studies. The solution is present in the link in the below, which you can follow. The next question is review the first 5 and the last 5 rows and check the values. The next question is find out if the data set is having null value. So you need to check at a data set level first, and then for each column whether any of the column is having the data set. After that, the next question is run the statistics like the mean, median, max, minimum, those percentiles and all will going to come over here. So what is the command that you will going to run, and what will be your interpretation via the mean, median and max? Only with the help of these 3 variables and obviously minimum and maximum, you can actually get to know a lot about each of the column that you are dealing with. Similar to the question number 2, check how many rows and columns you have in the data set, tells you about the entire data set. Running the statistics on each column and finding the mean, median, min, max, percentiles tells you a lot about the data set and the problem that you are dealing with. If you are doing an interpretation of that, that means you are really taking over your data set and can gain good insights out of it. Alright, next question is find how many people are having heart disease and what is their percentage, and even I would say visualize it. I've shown that in my solutions. Alright, next question is so the question 7 that you identify at a high level, bifurcated it by sex and check whether male or female is showing you a different pattern, and obviously create a visualization of it. And as you would expect, this is something to identify whether on an average male or female follow a different pattern in terms of heart disease. Now if I have to further go in depth of that question, then what I would do is probably I will come over here and look about the age. I would probably bifurcate by each age, right? I would create a age bucket category, let's say 25 to 35, 35 to 45, 45, 55, 65, or maybe 25 to 45, whatever category looks fine, because this is also a research kind of a problem as to if you have the males and females in their different age groups, do they behave differently, or is this something, a pattern that is emerging when you do this bifurcation? Again, this is, as you would have seen in your news headlines or health magazines, that's the kind of research that they do by further slicing and dicing the grouping, creating the custom group and finding what groups shows what type of properties, and accordingly they basically suggest the lifestyle, the foods and things like those. So this is something, this is just a starting point, like checking the heart disease by sex. But if you want to further go in depth, which I really recommend, is take a subset of this question and create the age groups by first understanding the age, mean, median, mode, minimum and maximum, because what it will going to tell you is what's the average age is, what the 50% age is, what the maximum age is, minimum age is. That will basically give you an idea as to what buckets you need to create. So let's say if your minimum and maximum value is like starting with 28 years and ending it, let's say 88 years for example, then you probably know creating 3 or 4 different groups may actually reveal a lot of insights, and you can actually play around with that by creating, let's say, first 3 groups, then the 4 groups, then the 5 groups, and see whether significant pattern emerges. If not, you basically stay with the lowest count group, like 3 groups or 4 groups at the max, not 5 group probably. So that's about the question number 8. A lot of discussion on that, but I think it's important that I tell you to develop your research mindset. If let's say if you are absolute beginner in this area. Now the next question is create the distribution for each variable and box plot of each variable, numerical variable, and see their shape and outlier. So now this basically helps understand the distribution of the data, basically what the column distribution is, and whether it is right skewed, left skewed, that means where the observations are mostly grouped and where it is basically not showing any grouping, or it's like flattened. So that's one thing, and box plot basically helps you look at the outliers. So if you need to do a bit of an outlier treatment, which is out of the scope in this case, I'm not putting it from a beginner friendly perspective, but if you want to understand the outlier, box plot can help you. The next question is, produce the scatter plot and histogram plot for all numerical variables in one chart. Now, this is something which I have shown in my solution case study, as to you take the entire data set and with just one command you can show all of the histograms and the scatter plot. So visualize this, interpret it, and understand what it is trying to tell you. Next question is, produce the correlation of each numeric variable. So that's also important, and you need to basically see whether it is where you have the high correlation, where you have the low correlation. Sometimes, as part of a caution, I've shown in the last case study, I guess the diabetes case study, where I think I've removed some variable because it was very high and may impact or may hinder the output or the prediction. All right, the next question is, produce the heat map of each variable. That will help you and your audience to visualize the correlation of each variable that you have created in the step 11. The next is, we are starting now with the bit of machine learning, where for each of the categorical variable, you need to create the dummy variables. After that, you need to start modeling by creating the x and y variable. Make sure that in the x variable you have the value from column A to column K, and all those dummies that you have created for categorical columns like this, and this. And the y will going to have only the heart disease. All right. So I need to make it back. Start modeling by creating x and y variable, and then what you have is create trend and test data set in 80-20 ratio. Now this can be something controversial issue, like many people argue, even when we create this, we argue like whether 80-20 is a good ratio or 70-30 is a good ratio, what it is. But I think everything gets solved when we apply the cross validation. So I have a cross validation video. I'll try to make sure that I remember that and put a link. And I would highly recommend that you do the cross validation in this case. But at least if you are a beginner, let's say you are doing it very first time, so I don't want you to feel like you are dealing with a lot. So creating an 80-20 is a good thing, which I understand that as a beginner, you start with this. And why we create 80-20? 80% is basically, 80% is basically to train the data, and 20% is basically to test the model that you have trained on the trained data. Now, 15 is you run these many algorithms. So you run it's like multiple steps. I thought of creating like 16, 17, 18, but I don't want to just create for the sake of creating it, the multiple step. But it's like all the algorithms, like you have logistic regression, random forest, SVC, linear SVC, decision tree, XGBoost, LGM classifier, and basically run all of these algorithms. They are pretty straightforward. However, understanding them in depth is a separate game. But at least you should know to start how you need to run it. And I've shown almost every of this. If I missed any, that may be my mistake, but almost every algorithm I have run it in my previous case studies. So you need to find the best algorithm and their accuracy score, confusion metric, and the classification report. That will going to help you as to what the output that it is producing. The question number 17 is, what parameter you will consider to tell which is a good model. Now this is an interesting thing, right? Because if you will see, and this may come as an interview question to you, as to what parameters you will consider to tell in this particular scenario. Because think about this, you are dealing with a person's life, right? If let's say you want to have a high level of accuracy and someone is not falling in that accuracy, then we may be missing that the person may have a high disease, right? So this is like a judgment call, or this is like a call. Even in this case of coronavirus, I forgot where I read about this, but it's like if only when the tests when the samples are gone, when they are taking those nose and throat samples, when they are gone, they basically run the test against it. And if their model is saying that, yeah, 70% symptoms, 70% or more, then they basically say, yeah, you have this. Otherwise, you don't have it. So think about this. If let's say this is true, which I don't know, I have just read it somewhere in the news, that if this is just 70% and someone has the mild symptom, which who knows, maybe tomorrow or day after may run into the more or severe symptoms, then we are probably missing out. So even in case of COVID, I am pretty sure a heavy research may have been done that if the symptoms have not reached 70%, then probably this is just a mild throat infection or a normal throat infection, which I would say in many millions of cases probably will not be the output as the novel coronavirus or the COVID. So that's just a reference I wanted to tell you, because it is it is there in my memory, and it is very close to having the heart disease. So it's like defining whether we want to have an accuracy or a precision or recall or things like those in terms of what we want to choose. And that's what basically confusion metrics and all they talk about, and that's why they are very important. All right, a lot about that. Question number 18. So show the important features in the model. So that's very important for an audience to know whether resting ECG impacts a lot, whether cholesterol a lot, or whether resting BP a lot impacts a lot, chest pain type impact a lot, which variable are really impacting a person's health. So that's something you can basically identify with the help of these algorithms. All right. Now the next one is take the top 5 features and experiment with all the previous model. Now why I am asking you to do this is because, see, what you have is 1, 2, 3, 4, 5, 6, maybe 7, 8, 9, 10, 11, I don't know how many you have, 12, 13, 14, 15, 16, and 17, 18, 19, close to 19 variables when you create actually the dummy variables. Not actually 19, but I guess 15 to 16, because you remove the first one because that's just not required. So you have close to 15 or 16 variable. Think about if you have 1 billion rows and 15 variables compared to 1 billion rows, you have 5 columns. Obviously, with 5 columns, your improvement in the algorithm or the speed of the algorithm will improve, and there is a good chance that some of the variables may be impacting the accuracy, and with the just 5 features you can create a much more cohesive model which is running fast and taking less input as well. So that's the reason I'm giving you this question. Now the question number 20 is, do you see any improvement in scores? Well, yeah, that's what you need to check, otherwise you go back to your original model. Question number 21, create a real life X variable. So maybe what you do is create this age, sex, chest pain time, and all of these variables up until here by looking at my last 2 case studies. If you are really not sure, let's say you take like 45, you take male, you take ASY, because ASY is one of the value, and all of these values one by one, and basically run the same code which probably I have shown you over there, and then try to predict what it is coming up. So maybe in one of the scenario, actually in both the case studies, what I've done is I have taken, let's say, one random row like this one, for example, and I'm checking whether it is really giving me the heart disease or not, right? So you can do it like 5 to 10 times and you will be all expert to check it, how to do it, let's say in the front end. And that's what usually it happens, right? Because based on this step number 21, if you are someone who is who has developed Flask application or Django application, or there are other interfaces like in Shiny or Dash. Shiny is basically for R, but Dash is in the Python. So if you're creating with applications like a dashboard applications with the help of those, you can simply take the inputs from the user, let's say a web application, and create an output, right? So that's something I want you to do it, because I am going to tell you in next couple of days one application interface. With the help of that, how you can develop an application, the machine learning application, and start producing the output like this. So that's about this case study. I think there is no further question. Just a 21 question to keep you busy for around good number of hours, like 4 to 5 hours, if you are doing all the interpretations and everything. And hopefully this should help you solidify your skills. So practice makes you perfect, right? The more you practice these things, the more you will be able to think, and probably one fine day you will even start feeling that my case studies are boring, but because I mostly created for the beginners, right? So if you're a beginner, obviously you will going to find it very interesting. If you are the one who are returning and want to regain your skill set, these case study obviously will going to help you regain or reskill yourself into the machine learning. So that's about it. Let me know what your thoughts, comments, suggestions are in the comments, and that basically helps me what type of content I should produce and the things I should give you, which eventually help me to share my learning and to skill you into someone who is a good, let's say, a data analyst, the visualization developer, the machine learning developer, the data scientist, right? Okay, so with that, thank you so much, and I'll meet you in the next video.